I'm going to present you the tale of a database that was a little bit too big, and we decided to make it a little bit smaller. And it was for safety reason, for cost reason. And let's talk about some urban legend. You may know that there are only two human-made objects that are visible from space. One is the Great Wall of China, and the other one is the relational database of Amadeus Revenue Accounting. I mean, I'm joking, you cannot see the Great Wall of China from space. The database, maybe. So, my name is Michele Costantino Soccio. Most people, they will get it wrong. They even got it wrong here. It is okay. I am a principal engineer at Amadeus, and I work at Revenue Accounting. If you want to write me an email, you can use this very long email, or scan this QR code, or use this very short email. Okay, up to you. So, who knows about Amadeus? Who doesn't know about Amadeus? Okay, everybody knows about Amadeus. We do travel and tourism industry. When you book a ticket, you pass through us. When you rent a car, you pass through us. When you book your cruise, you pass through us, hotel as well, and so on. Now, about revenue accounting. So, what is revenue accounting? Revenue accounting is the bridge that at Amadeus we do between the airline world and the financial world. So the airlines, they need to keep track of their finance for their operations. They need to make sure that they could run audits, for example. They need to make sure that they can trigger some actions that may impact financially some of their partners. So, for example, when you sell a flight, but the flight is operated by another company. I don't know if it happened to you. You book for France and then you fly with the Lufthansa, and then this one is a way to say, "Hey man, you owe me money." And to do this, we need to record every single financial transaction, all of them, for all the airline passengers' operations on the airline. Now you can understand that is a huge amount of data. So, is this huge amount of data a real problem for a relational database? It's a problem for the operability and for the system stability, because if there is a disaster, it's very hard to go back to run the backup, and it's very hard to do the recovery. It's also a problem for the cloud, because it is easier to copy data when you migrate to the cloud if the database is small. And also if the database is small, you can also aim at using those very sweet NVMe storage that for now they are only up to 19 terabyte, I believe. So if you are less than 19 terabyte, you can use that. And of course, it's also a matter of cost, because the money you spend for the storage is it can be quite a huge sum. So we realized this one quite a long time ago. It was in 2015. I did a little bit of archaeology in our documentation, and someone was saying, "Oh, careful, the database is already 14 terabytes. We should stay around 10 terabytes." They were so naive. If we didn't do what I'm going to present you, if we haven't done it, we would have been at 63 terabytes in our database, okay? And today we are more around 38 terabytes, which is already quite good. So, the gist of it, keep it small. At a certain point, we needed to understand, decide where to start it. And we decided to start with the biggest elephant in the room that we could find. So, we had some, we had some tables in which we record all the financial documents, all of them. We have one new copy, one new full copy for any new event that happens. You buy a ticket, you ask for a refund, you take that flight, you exchange because you change your date, everything, a single thing. You receive a payment, the payment got confirmed by the credit card company. Every single one is a new version. So you see that the data is accumulating quite fast. Those tables, they store the data in protocol buffer blocks, but they are on Oracle database. And they were accounting for 30% of the total DB size. So you look at, logical to start from that one. So we have several tables. They have some very relational relations between them, and so they are very well interconnected. And they were accounting for about 20 terabytes if we didn't do anything. But then we realized after a while that there was some other tables not that big, but with no dependencies, no versioning, much easier to do. So we started with the one on the left. We should have started with the one on the right. So my first lesson, start with easy elephants. Even if they're smaller, it's better to start there. So let's have a look a little bit. One of those tables is a very typical table. We only see one, but there are many others. And we have many versions for the same document, and each document is stored in a protocol buffer message. Everybody knows what protocol buffer is? Yes? Yeah, good. And they are GZIP. Everybody knows what GZIP is? Good. And you can see that they are actually quite small, 1.3 kilobytes each, but we have billions and billions and billions of these rows, so it gets very big. And then, because you cannot search so easily from a GZIP file, then we have, beside that, we have some tables that is just for indexing. So here you have, you don't have all the versions, you just have some of the data, but you can do an easy search, then you can get the ID, and you can retrieve the protocol buffer you need. And this is very good. And it's very good because if you keep the data separated from the indexing, it's very easy to move the data away and still be able to find your data, okay? Now that we know we can move our data in another place, do we need to keep those data in Oracle? And where would you put it if, for example, if you want to move out of Oracle some of the old data? What would you suggest? What storage would you suggest? Any idea? Excel? Excel? We have a limit of the number of rows, I believe. Multiple files of Excel? I have someone here who suggests Blob Storage. Okay. Yeah, Blob Storage or object storage. In Amadeus, we call it object store, like it is a place where you go to buy objects. Anyway, it could be S3, it could be Scality, it could be Google, it could be whatever that is called on Azure Blob Storage, that is the one in Azure. Okay, and so this one was what we called the archiving. So, about object storage, what we have to say about it is very slow. But it's old data, so is it acceptable? If I tell you that it's very cheap, it's very much acceptable. But how cheap it is? Let me show you. So here I have the pricing calculator. If I had to use some, could I do like this? Yes. It would be a little bit weird, but it's okay. So I have the pricing calculator here. If we had to use the disk for Oracle, we would need, for example, let's say 25 terabytes. We would need 3 disks because we need 3 different machines in 3 different zones to have a redundancy, and it will cost over 6,000 euro. The same amount of storage in S3 with same redundancy, the ZRS, which is 3 zones, sorry. It is almost 12 times cheaper. It's really, really cheap. So it is very cheap, so we went to the people that handle the object storage in Amadeus and we said, we want to use it. Oh, very good, we are happy that you want to use it. What do you want to do? We want to store billions and billions and billions of tiny files. Oh, no, don't do that. okay? Because object storage will not, the Blob Storage will not work very well with a lot of very, very, very small files. It would really be nice if you could do just files that are exactly 40 megabytes. Okay, that was the limitation at that moment when we started. And so how do we do it? Of course, you zip them all. And then when you need just a few kilobytes, you need to download 40 megabytes. It's not an option. If only there was a way with HTTP to get only one part of a file. Yeah, there is a way, RFC 7233. That is superseded by RFC 9110, I believe. It allows you to do that, so you can store the file as is, and you can just need to remember what that file, what the data you need are in that file, and retrieve only that part. So the query will be something like this. So you have, this one is the file, okay? And here you say the range bytes, and you just say, give me only starting from here until here. And it is as fast as just getting one part of the file. You need to keep track on it. And so we made another table. And to avoid having too much space, because if not, it would have done the opposite of what we wanted to do, we decided not to keep track of all the different components that are all related, and to store all the versions together. But storing all the versions together, it means that once it is uploaded to S3, we cannot modify it anymore. Do you understand why this one is? Why we cannot modify it anymore? Exactly. You change the range. It would change the range because that part of the object would increase. But then you have to move all the other enablers. You basically have to rewrite the whole file. So we decide it will not be cannot be written anymore. It will be read only, and we asked the airlines, is that okay? Because remember, if it is not your data, you have to discuss with your customers. It is their data. They need to understand what you're doing with it. Eventually, it's time to free up some space. Is this a good way to free up some space? Huh? It is very slow, and it actually does not free up any space. Okay, Oracle can be compact in something, but you will not free any space on disk. So instead, what you do, it is partition by range. Partition by range is basically a new way of partition that is available since a few years now on Oracle. It allows you to create automatically partitions every month. In this way, you have all the data that have issuance date, for example, the 19th of May 2018 will be in this partition automatically. And it will create new partitions as soon as you have an issuance date in a new date range. It's absolutely fantastic, it's very fast, you don't need to worry about partitions anymore in your life. Totally recommended. So, we now have the solution. We drop the partition. Almost. Because the problem is that once you do this one, this is not reversible. Again, it's not our data, it's the data of the airline. The airline wanted to have a kind of safety net. And so, exchange partition. Exchange partition, how it works. You create an empty table that has the same structure of the original table, okay? This is the partition you want to clean. And once you have done that, you do exchange. Let's hit one more time. Exchange. In this way, after that, you have the content of the partition in the temporary table, and the new partition in the table is empty. And you have completely freed up the space once you are ready to drop. You want to see it again? The drop? Drop. So, I'm very proud of my animations, yeah. So, now we have eventually our solution, a solution that is good. you create an empty table, and then you do an exchange partition, and after that, maybe 1 week later, 2 weeks later, 1 month later, whatever is your policy, you drop that partition and you have freed up space. So let's recap how we do it. You select a partition that is more than 4 years old. Okay, we only archive, we only move to S3, to Blob Storage, something that is old. Then you build, oops, spoiler. Then you build all the Fridays, all the ID, all the documents that are in that partitions. You put them in a file, upload. You put them in several files until you fill 40 megabytes, and 40 megabytes upload to S3. You mark them as archived, so that your application know that they have to look in S3 and not in Oracle. And you can exchange and drop the partition. You have free up some space. This solution actually proved later also good for another problem. If we take only the first and the last piece, and we say that we only select data that is 10 years old, you have solved the GDPR problem. Very easily, very quick, you free up space, and you are GDPR compliant. And remember, the GDPR is your friend in this case, because you free up space, okay? Usually don't like it, but this one, oh, thanks GDPR. For those airlines that say, oh, we want to keep the data forever. No, we cannot, we have the GDPR, we have to delete. Okay. And so GDPR is your friend, and the partition by range is the best friend of GDPR. Very good. At this point, let me see the time. It is quite okay, 3 minutes ahead of time. This time we were ready. We almost had convinced the airline, can we move the data and free up some space, because the database was getting fatter and fatter and fatter, and then the airline says, stop! How about those special cases? Which special cases? I don't remember. Well, you never told us. Yeah, we have some special cases, we have some documents that are very, very old, but for which we still have to do something. We still have to do an exchange. Maybe they will ask a refund, or maybe they still want to use it. Sorry, why they want to do something? Why they want to do something like this? But what happened in the wild? Yeah, that happened. So, exchange partition to the rescue. What we do? The documents in blue, they are the documents that we can archive. Okay? They are being used, there is nothing more that could happen. The documents in red, they are the documents for which something could still happen, so the airlines, they want to update them. So we need to keep them in Oracle. How do you do it? The yellow one is the partition to clean. You copy your data to S3, the blue one, you copy the red one to the table for exchange, and exchange. And after the exchange, you have the blue one in S3, the red one still in Oracle, and a backup copy in the table for exchange. After you're ready, you can get rid of the space. Guess what? Drop. And you have freed up space. So, absolutely wonderful. And this was one of the biggest achievements we have done. So, a lot of people worked on it on many, many years. And, but after that, we were asked, but how about those documents that are still recent? Those documents are still in Oracle. They occupy so much space. There must be a new way of compress it that could literally make the difference. Because, you know, for each new event, each new thing, everything that new happen, you will have a new copy of the document, a full independent new copy of the document. That is such a waste, even though it is compressed in GZIP. And actually, because the difference between each version is very little. It could be like payment pending and payment confirmed. Just one line and you do all that. Is there a way that we could store only the differences instead of the full version? Is that? Yeah, there is. RFC 3229, aka VCDIFF, which is completely format agnostic. Do you want to see some code? Yeah? Okay. I'm not very good at coding, so you may have to help me. Now, how do I... So I have to move this window here over there. If I find how to do it, because it is in full screen. Here. Okay. We can remove this one and just do a little main. Come on, Copilot. Do something. 10, 0. Perfect. Now I save this one. I will explain why I do this one later. And this one is the... So here we will write how to compress and decompressing using VCDIFF. And I wanted to do... I don't know if it will work, because it depends case by case, but I want to do something extreme. I want to see if a VCDIFF could do better than a JPEG. Okay, so I have this, let me move it here. I have this, I have this image, okay, I looked for Code Azure and they gave me this one, okay. And now I want to export as, I will save it as a JPEG. Okay. Yes, replace it and save it with this setting, 90. Export. Very well. Now I want to do a little bit of drawing. Doing my page, I said that I would have done some drawing. Now I would have used my finger on the screen that is touch, but that one is not touch. So I'll do my best. So here I have, I will draw a little heart here. Does it look like an art? Perfect. Okay. Now I will save this one and export. And I will call it Riviera DEV.jpg. Save in the same way. Okay? Now, what? Sorry. Let me delete some files of the last time I tried it. And it should be okay. Yeah. And so this is the files I have. Let me do ls again. So we have, this one is the original file. This one is the file we just modified. These are the CPP that we will be doing it. I should remove this decompress JPEG. Okay. Very well. And now we will go to fill compress.cpp and decompress.cpp. It would be very hard. Anybody knows how to switch the screen thing? Windows key and P. I'm doing it, it's not doing anything. Let me try. I have 2 minutes ahead of time, so I could waste it. Because I have one key here, which is not working. Anyway, okay. I will do a little bit like this. It should be okay. Anyway. So we have this file that is empty. So I will create some basic include IS3. But thank you. Copilot is really fantastic. You should try it. String, yes, I need string. No, I don't need vector. I need the io.hpp in which I wrote some helper functions to read write files. Okay. I add my main. No, I don't need this one. Yeah, exactly. And expect 3 arguments. The base file, the target file, and the delta output. Output, okay? Come on, do something for me. Yes, perfect. Now, what I will do, let me remember, yeah. What I will do, I will read the first file and put in a string that is named base. Sorry. String target, yes, and an empty string is standard. I told you should have helped me. Delta. Okay. Standard. And now, to compress, what I can do, I can go here, search open VCDIFF. Is by Google, by the way. I mean, the standard is an RFC. The implementation we use is the Google one. And I just go to get these 3 lines here. Copy and paste. You want to see it again? Copy and paste. Okay? Actually, we don't need this one, just the encode. And success, bool success equal this one, so that then we can do if success. Yeah, exactly like that. Very well. I need the include Google/VC encoder.h. Yes, and now let's see if this thing builds. I will be very surprised. Yeah. What is it that he doesn't like? Yeah. And yes, because the example is using a dictionary. I'm using the string is named base. I like base better. Base, okay. Let's try again. Yay, it did it. So now we can go to the prompt, whatever that is. Is here? Yeah, it is here. And now in build, I have my compress, okay? And I can do the base file. The target one, the Riviera DEV, is the one that where we added a heart. Is it okay, the font like this? Yeah, good. And then the output, it would be just, I don't know, file.diff. This one is our delta. Yeah, let's see, because sometimes it doesn't. Yeah, I'm not on Linux. Sometimes it doesn't work the way I want. Where is the delta? Compress, this one, that one, file.diff. Sorry? In the build directory, no, I don't think so. It shouldn't be there.
You don't use the third argument in your code.
Oh, yes, I don't write it. You're right. It actually does it, but it never writes it. So if it is like this, I have a little screen that is more convenient. So I just do write argent sys delta. This one should be okay. Thank you so much.
Line 17, why don't you use the third argument? Do you use the first one, the second one?
Yeah, the third one I'm using here.
Okay.
I write it like that. Yeah, no, it's a good point. So now let me see if I do the compress, ls. Yay! You see the file.diff is much, much smaller. So do you believe me that worked, or do you want me to do the decompress? Let's do the decompress. So I think I will just copy this one. Sorry, because not having it here is very, very cumbersome to use. And instead it is base file, delta, and target output. So in this case, we do like this. And we leave the target like that. We include the VC decoder. And that should be, we get to see here, we can make it bigger. We just need these two lines. Okay, open VCDIFF, we create decoder, then bool success is equal decoder, not dictionary, but base. Sorry. Base, delta and target, yes. And here will be decoding failing. Decoding failed. Okay, and we save the target in this case. We build. Yeah, first try. Never happened in my life, I should record it. Okay, and now we do the decompress. Build that decompress. So we always need the first, the baseline one. Okay, gem. Then we need to give it the diff, and then we want to put new file.jpg. We will write in a new one. Let's see. Did it create the new file.jpg? The size seems correct. Let's try to open it. Let's try to open it. I could actually open it directly from here. It's more convenient. New file. And we have our little heart with a fraction of the space occupied. Woo. I asked for the hot room. They said, yeah, don't worry. So let's go back to this slide. It's okay. So how did we use VCDIFF? This is what we have in database. The difference are the small changes we have. We keep the version 0 as full, and we only store the difference from the version 0 to the other one. So when we retrieve from database to reconstruct it, we give me this version plus version 0. Give me this row plus version 0. It's always the same. It's very fast. And we couldn't measure any difference in terms of speed. So it is comparable speed to GZIP. It's really, really fast. But compared to GZIP, we have at 50% less space than a GZIP, at least. It depends on how many versions you have. The more versions you have, the more changes you accumulate, the less effective it becomes. But you have only few versions, there are very few changes, and each blob, instead of being 1.3 kilobytes, it becomes like 50 bytes. We are quite happy about it, and we have used it on billions and billions and billions of documents, and so far we have yet to find a problem. One problem we had, however, was how our libraries were structured, because we had one library that was in charge of retrieving the document, that was calling another library that was going to decode the protocol buffer, and if it was GZIP, we were calling yet another library to do that, which was very inconvenient. Because that library should actually not care about compression when you decode the protocol buffer, because once you pass the VCDIFF, because you need to pass two things, the base and the diff, you have two streams that you have to pass along. Now you have to change all the signature of all the functions, and this was very, very painful. Instead, do the other way around. You call the decompress, and then you decode the protocol buffer. So if you want to recap, that is the bad, this one is the good, and this one is the best. In which instead of nesting the calls, you just do them one after the other in a very functional way. Read from database, pass the results to another function that they will decompress, pass the results to another function that will do the decoding in a very flat way. And that is absolutely my recommendation. If you see a way that you can refactor and is not really revolutionizing everything you have, I mean, it must be a good trade-off, go for it. And the function-oriented, even in C++, is something that is much, much easier to test. This is the end. If there were a few concepts that I would really be happy if you could remember after this talk. Use partition by range is very good to get rid of data, of all the data. Design always with GDPR in mind, because GDPR is your friend. Keep your recent data on fast storage. Keep your old data on cheap storage. Keep your useless data nowhere. And if you have versions, there are ways to keep only the difference. Don't do a copy every time. Okay? There are more efficient ways of doing it. This project lasted many, many years. A lot of people worked on it. I don't know if, Michele, if you worked on it as well. Yeah, I will add your name on this one. The list is getting longer and longer every time. Oh, I also worked on it. Okay? You can recognize some names. At least this one. Huh? And thank you so much. If you have any questions.
Just to know, do you plan it to do the same thing on a larger scale? I don't know, on other databases in Amadeus?
We are going to plan it because we want to be ready to host airlines that are larger than what we have. Okay? Because so far, the example I gave you is a database that is actually hosting only 4 airlines. Vistara, South African, that is kind of bankrupt and is in special administration. British Airways, which is very large, and Saudi, which is also very large. But if we want another airline that could be larger than those, even if we have a new instance, at the beginning, is okay because you don't accumulate much data. But if it gets larger, you need a better solution. Okay, we also use other databases to do querying and reportings. And for those, the space for now is okay. But for larger airlines, yes, the space will become a problem also for that. And the solution will probably be keep fresh data in an expensive storage and keep old data available, but in a cheaper one.
I have a question. Did you compare the performance from VCDIFF plus GZIP compared to TAR plus index files and something like XZ2 or Z standard?
We compared GZIP compared to ZSTD. This is the zip file zip format compared to other of Facebook. That would be a very good choice for keeping the version 0, which is still in GZIP, which is accounting for the most of the space. And we found that it is a little bit faster than GZIP, and it is it could compress 7 to 8% more, which is not very good, but it's not something that I would throw away. Yeah, but so far what we gain by that change will not justify the changes that we have in our system and the cost that we have to go to change our system for that savings. But yes, we not all those that mentioned, but a few of them, yes. BZIP is absolutely the slowest one, but has a very good compression. But with ZSTD around, that is the choice for me now.
Yes, hello. I was wondering if you have many versions, would it be sensible to have the VCDIFF with the previous version instead of just?
Yeah, we thought about that. The problem is that we would have then to do it many times to retrieve all of them, and we were afraid that it would have taken a lot of time. The best solution for that is a little bit different what we have done, but we can still modify that. Is that in the table when you store the blobs, you put beside one more column, and you say this version is built on top of this one, and then you add a full version every, for example, 10, because we saw that when you go with a 20 version, the 20th version in VCDIFF is larger than what you would have had in GZIP. So is not a good point to have that one. So the best solution is what we thought about what you were saying. We also thought the other way around. Keep only the last one and do the VCDIFF of the old ones. Yeah. But we decided for this one had the most advantageous trade-off. Another solution that I would recommend is to have intermediate milestones, let's say. In that case, you have to see when is more convenient to stay, how many versions is convenient to stay in VCDIFF, how many versions you should stay in, and how often you should actually make a new full version.
Okay, thank you.
I didn't understand exactly what is the difficulty of storing very little files on the S3.
I think the problem was that Amadeus, the time when we worked on that part, it was before Amadeus signed the contract with Microsoft to move to Azure. Okay, so we were using an internal version of S3. We don't know what is exactly the reason, but when we asked the people that were managing that, we need like 50 terabytes. Oh, no problem, 50 terabytes is okay. Yeah, we will store 100 billion files. How big enough? 10 kilobytes, maybe if we group a little bit all the versions together. No, don't do that. It will absolutely be very bad for the performances. Probably things changed in the version that we have in-house in Amadeus, and things probably changed with the also with the Blob Storage, Azure Blob Storage. That is the engine that we are going to use after we have finished migrating to the cloud. Yeah, but is what they told us.
Hello, thank you for this presentation and the great animations. I need more clarifications on a specific slide, where you define the exchange partition with where you store the active data, in red, and you say, okay, we store also some backup, I think, on S3, and you drop the temporary data to free up the space. Yes, exactly. What do you do with the data on S3? Because you say
The data on S3, they stay there until they are 10 years old. In that case, the GDPR will also intervene in S3. But we are not much worried because S3 is extremely cheap. Still doesn't mean that you can waste space, but it's very cheap. Okay, so the data will stay there in S3 for very long time. They're still available. We can query the data, we can retrieve them, and so on. But what happens here is that in that same partition, okay, because we are doing it really per block. If you don't work at the whole partition, Oracle will not free up any space on the disk because we'll just not recompact all the rows. You can ask Oracle to do that recompact, but it's something that takes on our database will probably takes days to be done, and is something that usually don't do unless there is a specific reason. And so what they wanted to do was I want to keep those red ones on Oracle because tomorrow, in 1 year, in 2 years, I must still have to process a refund on that specific ticket. I don't know when it could happen. When I buy a ticket, usually, it's not refundable, it's not exchangeable. Once you buy it, even if you don't come, it's your fault. Okay? And so they will do this exchange. We do this exchange, and the backup copy that I was mentioning is actually this one. Okay? This one is not a backup. This becomes the real source of the data. This is the real source of the data for the red one. This one is a backup that we keep today for 2 weeks before we drop it. But even during those 2 weeks, when the application needs to read some data, if the ticket is archived, we'll go to S3. If the ticket is in Oracle, we go to Oracle. We actually don't read that table. We have some tools to do comparison, checksums, and make sure that everything is okay, but no applications in production is actually reading that backup. So this is the backup. The backup is still in Oracle, and it is in Oracle because if there is any problem, very, very fast, we can copy back all the data. And to copy back all the data, what you do is that you freeze for a moment this partition, you copy those red ones that could have been changed in the while back inside the exchange table. Okay, you overwrite the old one because they've become stale, maybe you have updated. The blue one, you are sure they've not been updated. Okay, and then you swap it back. And if you really want to do some cleanup, you remove them from S3. But when you swap them back, you remove from the indexing table the address where you store those files, so we are never able to retrieve them. You can do some cleanup later if you want. So far, I believe we have never used it unless there was a few, maybe only for a few tickets, in which the airline, I need exactly that one. If it is only one ticket, you don't do again the swap of the partition, you just copy that single ticket.
Okay, clear, thank you.
Okay. I think the time is over. Yeah, but I will still be here, don't worry. Thank you so much again, and happy rest of the day. Bye.